at this point, I want you to do 2 practice problems, and it's up to you whether you do the first practice problem and then start the video up again and check your work, and then try the second practice problem and then start the video. It's up to you if you do both or one at a time. But what I really want you to try to do is on the second one. This is a bearing problem. Do your best to try and draw this problem on your own before you watch the solution. See how you do. It's worth, fighting through it a little bit. You learn so much more from attempting, and even if you fail and don't do it right, you learn a lot from the process. So don't just jump into watching the video. I know I've said this many times, but it's really important that you see if you can draw this. If you don't draw it correctly, it's okay. Once you see it done, hopefully you'll be able to draw one correctly in a problem that does not have the diagram drawn out for you. So pause the video and start it once you've completed the problems. So for this first problem, we're going to use the law of cosines to find the largest angle, which again is the angle opposite the largest side, and so angle B is what we want to find. So I'm going to write down the manipulated version of the law of cosines. So we've got the cosine B equals a squared plus c squared minus b squared all over 2ac, and I have entered the values in for the variables. Now we'll evaluate this on our calculator. Okay, and we know that if the cosine B equals this expression, we want to do second cosine. And so I'm going to open parentheses for the numerator. It's going to be 100 plus 64 minus 16 squared is 256. Close the parentheses, divide by, I'm going to open the parentheses, 2 times 10 times 8, and close them. Close one more time, hit enter. I'm going to actually go through this and look at this error, because you could do the same thing. This is a syntax error, which means I typed something in incorrectly. So if I go to it, it'll tell me what I did wrong. And look, I hit an extra set of parentheses there. And so without starting all over again, I didn't realize I had hit a double hit. I can just hit delete, and I should be okay when I hit enter. So rather than just start the video over again, it's nice to see a mistake made and how you can correct it. And so now we have angle B is equal to 125 approximately. You could have, if you wanted to, just evaluate the numerator first, 10 squared plus 8 squared minus 16 squared, and hit enter. There's your numerator. And then you can evaluate the denominator, 2 times 10 times 8. So we'd have the B would equal the inverse cosine of negative 92 over 160. So second cosine, negative 92 divided by 160, close them, and we should get the 125 again. So really, it's about you being comfortable. Choose which method you prefer. Let's write that value down. Now we've got the obtuse angle, so it doesn't matter which angle we find next. We'll use the law of sines to find it. So step 1 was to find that first angle using law of cosines. Step 2, we're going to use law of sines, and I'll find angle A. Setting up my ratios, I get 16 over the sine of 125 is equal to 10 over the sine of A. We'll evaluate this on the calculator. So second sine 10 sine 125, close the parentheses, divided by 16, and then close parentheses again. I'll hit enter. And we're rounding angles to the nearest whole number, so it would be angle A is approximately equal to 31. So we'll put our 31 degrees in the triangle. And then step 3 is to find that last angle, which is C. So 180 minus the 31 minus the 125 equals 24 degrees for angle C. And I highly recommend checking your answer using the law of sines ratios. Alright, let's look at the second problem here, and the hardest part about this is drawing the diagram. And so we've got a fishing boat that leaves its pier and heads east. After traveling for 30 miles, there was a warning of rough seas directly south. The captain turns the boat and follows a bearing of south 45 degrees west for 12 miles. At this time, how far are you from the boat's pier? And round your answer to the nearest tenth. And then the second part is, what bearing could the boat have originally taken to arrive at this same point? So I'm going to start by labeling the pier. So this would be the pier. And the boat travels for 30 miles and heads east. So we're just going to say a horizontal line heading east. And this would be 30 miles. At this point, it says the captain turns the boat and follows a bearing of south 45 degrees west. So I'm going to draw in my north-south line, or broken line, to help me draw my bearing. And I know I'm going south 45 degrees west. And so I'm going to draw a line that would create a 45-degree angle right here. This angle right here would be considered south 45 degrees west. Right, from the south, and then we move towards the west. And that distance right there is 12 miles. So at this point in time, this is where the boat is, right here. And so we want to find the distance from the pier to the boat. So we want to find this distance right here. That's our unknown. Now we can label this A, B, C to help you work this out. And so our job is to find little b. This is what we don't know. But what we do know is that this little angle in here has to be 45 degrees because we have the north-south line and a line parallel, or perpendicular to that, creating a 90-degree angle. So I know this little angle in here is 45 degrees. And so what I have is a side angle side triangle, and if it helps you to see this triangle drawn without all the bearings in it, then that's a good idea to draw it again. So we'll draw this triangle the best we can. This is 30, this is 12, this little angle in here is 45 degrees, and we're looking for B. We've got A, B, and C. And so we're going to use the law of cosine to find side B. So we've got the formula for solving for B. Enter the values. 12 squared plus 30 squared minus 2 times 12 times 30 times the cosine of B, which is 45, cosine of 45 degrees. Evaluate on our calculator. We'll take 12 squared plus 30 squared minus 2 times 12 times 30 times the cosine of 45. Hit enter, and then take the second, raise it to either the 1/2 power or do second x squared, which is square root, and then second, and then the little negative sign, which would give you the answer. And hit enter, and you get approximately 23.1 would be the length of B. So the distance between the boat and the pier is approximately 23.1 miles. Now it's our job to figure out, it says what bearing could the boat have originally taken to arrive at this spot, round the angle to the nearest whole number. And so what we really want to figure out is what's the bearing from the pier to the boat. So I'm going to draw in a north-south line. So we want to find angle A, and that will help us figure out what the bearing is. And we'll find angle A using the law of sines. So we now know that B is equal to 23.1. So we'll set up our ratios. 23.1 divided by the sine of 45 equals 12 over the sine of A. Sine of A equals 12 sine 45 degrees over 23.1. So we'll enter this in the calculator. A is going to equal the inverse sine, so second sine of 12 sine 45 degrees divided by 23.1. And we're rounding angles to the nearest whole number. So our A is approximately equal to 22 degrees. So if A is equal to 22 degrees, so we've got this little angle in here is 22 degrees, we need to find the bearing. And the bearing either comes from north or south of this line right here. If we came from the north, we can see that we'd have 90 degrees plus 22, and you can't have a bearing over 90 degrees, so we're going to have to go from the south, so we'll figure out what this little angle is in here. So if this angle right here is 90 degrees, then we know this angle in here is 90 minus 22, so this is going to be 68 degrees. So from the south, our bearing of where we are now, from the pier to the boat, is going to be south 68 degrees, east. So part B, the answer, south 68 degrees east.